Hello, everyone. Thanks for joining us today at Google Developers Space. Our first topic is about Kubernetes 101. Today's speaker, Sachin Choube. Over to you, Sachin.
Hi everyone, welcome to Kubernetes 101 section. My name is Sachin Choube and we will be discussing the basic of Kubernetes in this section. So how exactly we reach or how exactly the evolution of container happens. First, on the left hand side, if you see, there was era of monolithics where we have a hardware. On top of that, we call it bare metal. We have a OS on top of that and we deploy application on top of that. That was the legacy way of working. Then comes virtualization. So what really happened in the case of virtualizations, we had hardware and OS. We got one more service on top of that, that's called hypervisor. On top of hypervisor, we used to deploy multiple VM or virtual machines on that. In the virtual machines, again, we have a OS, we have binaries, and we have the app deployed on top of that. Okay, so the same hardware can now deploy multiple machines out there. That was the era of virtualizations. Third was containerizations. In this third category of containerizations, what really happened is the hardware remained the same. We have the operating system, we have the container runtime. So what used to happen, you deploy the container and then you have the runtime which will help to work. So if you see these two differences, we now don't have the OS. Okay, so we remove the OS and now only a minor small version of container. Again, container have its OS. I don't want to get into that, but they still use OS. Then we have a binary and we have the application deployed, but the OS is very light, which have minimum features out there which solve our purpose. So this is how we evolve out there. Now, why Kubernetes? The best part about Kubernetes are the following features. Once you deploy any services to Kubernetes, it will have the capability of load balancing at the same time. So once you deploy a service, you just do the required configurations, and henceforth, whenever you make the request, you will connect to the appropriate service and get your information back. Similarly, you can also do load balancing out there, so you don't have to have explicit services out there. Kubernetes have the capabilities. You don't have to buy in the externals, but it has the capability of having the load balancing out there. It not only gives you that, it also gives you storage orchestrations. Okay, what exactly it means that you can have multiple options for the storage. You can take the help of the storage which is there in your machines. Okay, if you want to have NFS, you can use the NFS. You want to mount your container with key vault, you can do that. If you want to mount with secrets directly out there to container, you can achieve that. So it give you the provision which you can utilize as per your requirement. Okay, so it requires certain, we call as container storage interface, which you have to add it on top of that to achieve this. One of the best feature about Kubernetes is automatic rollout and rollback. What exactly it means by rollout and rollback is just you give the instructions that I have this specific image, please deploy. And if you have configured the container or Kubernetes environment properly, it will automatically deploy out there. Similarly, you can give the instructions of rolling back and your application will be rolled back similarly. Self-healing in the sense, once you deploy your applications, you want to monitor it regularly. How exactly you will do monitoring and you have to have a third-party tool to do monitoring of that. If there is any service got stopped, you have to have a service which will trigger, it will kill the existing instance and give you that. That option is by default provided by Kubernetes, where if you can monitor if the service doesn't work, Kubernetes will kill that instance and create a new instance for you of a container. Okay, similarly, automatic bin packaging. So you can define in your each container, you can define that how much resource it will consume, that it will have one CPU, it will consume only 512 MB of RAM from the complete node. Till that extent you can define. So we will discuss later. There are multiple options offering from Kubernetes, and each offering you can define the resources, how much each offering or service of Kubernetes you can consume out there. The next part is secret and configurations. Whenever you deploy any service, it will require certain informations to be configurable. When that information can be confidential, just like your connections to your database, which have username password, which is a confidential information, you want to save that. You can also have certain certificates which you don't want it to be exposed to everybody. If you are using private certificates, so you don't want that private certificate to be known to everybody. So such informations can be managed in Kubernetes. And last but not the least, Kubernetes is the best fit for microservice architecture. There are other, but this is the best fit. Kubernetes cluster is a distributed system where management of the system is called control plane and the execution of the system is called worker node. So if you take a diagram out here, you can see this is management and this is the execution part of it. So in master node or a control plane, we have 5 modules. The first one is etcd database. So it is derived from bvault db. It is used to store all the information about the complete infrastructure of the cluster. Second is scheduler, which also called as Choube scheduler. The purpose of scheduler is which or where exactly the Kubernetes offering to be deployed, and based on the algorithms, it have 2 different algorithms by which it decide where exactly your containers or whenever you or your jobs will be deployed. So that is used for that. Third is API server. API server is the server which communicates with the external world. When you are communicating with Kubernetes cluster, you will be communicating with the app server, API server, and it will further communicate back to all other modules of Kubernetes. At the same time, it also communicate with worker nodes. Okay. The next module is controller manager. So controller manager is used to manage the desired state. So it have further services in it, which will based on if you can take example of replica controller. So if in your deployment you have defined that I need to have 5 copies of it, so the replica controller will always make your desired state of 5 copy of your container to be deployed in that. The fifth one is cloud container manager. This service is by default is used majorly by a cloud provider. If you are working for a cloud provider, then you might be required, but otherwise for normal usage it's not very friendly, it's not very used. Now comes to the part of worker nodes or execution part. It have 3 services. Container runtime is the service by which your container will be running. It will be executing based on the container runtime. Okay. Then is kubelet. Kubelet is the one which will be calling. So if you see from the diagram itself, so the API is making call to the kubelet, and the kubelet is, if you are, for example, if you are making a request to create to deploy 3 instances of any image, so that you will get the instruction to kubelet, and kubelet will talk to container runtime, and the container runtime will build the container and deploy in that pod. Okay. Similarly, kubeproxy is more about communications. If you can see this example where client is communicating via service and the service goes to the kubeproxy, and the kubeproxy will go and talk to the specific container out there. The service will decide where exactly your pod or your service resides, and similarly it will communicate to that specific, because each worker node will have these 3 services. So you can in normal cases, what I have observed or what I have heard is there are few clusters or infrastructure farm out or cluster out there which have more than 10,000 worker nodes. So in that specific scenario, it becomes very complicated to where exactly your service is deployed and which service you are going to use out there. So now comes the offerings. Kubernetes offer 4 activities. First is jobs. Jobs are one-time activity or any short scripts which you want to run and want to perform certain activity out there. So what exactly in this offering happens is Kubernetes will run specific service of yours, okay, or define script for a specific resources. You can define resources, which resource you want to use out there, and it's a one-time activity. For example, you want to perform that multiple times. It's like a backup of your database. You want to have this job done every day. So what you will do is, now your activity require a schedule. You have to schedule this so that every day at specific time your database backup to be done. So you will write the script in that. So this activity is done by cron job. Next offering from Kubernetes is pods. Pods contain it have container in out there. A best example for anything to be deployed in pod is anything which is going to be front-ending to the customers, or it will going to be communicating out there. So you will always deploy in pods. Okay, the best example is if you have developed any website, so you can use that. If you have API services, you will deploy in the pods or container out there, and which will consume out there. The last is a daemon. Daemon is a service which will run in the background. Mostly it is used for what the right term should be is administrative activity. Just like if you want to log certain information, so for log, it's like for example of fluentd or locky, which are used majorly for logging their databases. Fileco, which is again a security service out there, where it is managing any security thread or any incidents happen out there. So this kind of activity will do that. For this video, I have referred this many sites. So because I have used them very detailed, so I like to give you the references from the source from which I have taken this information. Thank you all. Bye. Then.
All right, thank you so much, Sachin, for delivering informative session today. I hope it is useful to everyone. Please feel free to follow us by any one of the links here. Thanks for watching. Enjoy your day.